Namaste and welcome in the second session of problems on Z transform. In the previous session, we have discussed how to get Z transform and the ROC for the first two sequences. In this session, we will discuss how to get Z transform and the ROC for the finite length sequence. So let's consider our sequence x of n, which is a finite length duration which is existing from n is equal to -2 to 4. So by the definition of Z transform, we can express x of z as in summation of x of n into z raised to minus n, where n is taking the value from minus infinity to infinity. As given x of n is existing from -2 to 4, for n is equal to -2 to 4, we can rewrite this summation as summation of x of n into z raised to minus n, where n will take the value from -2 to 4 because of the length of the given sequence. Now over here, we will simply expand the summation by substituting the value of n in this expression. So therefore, we can have x of z as expressed over here, that is x of -2. When starting from n is equal to -2, we can write x of z as x of -2 into z raised to minus of -2 plus x of -1 into z raised to minus of -1, and so on. We can have x of z. So simply in the next step, what we have to do, we have to substitute the values of x of -2, x of -1, x of 0 from the given sequence. So here we are having the value of x of 2 is nothing but 2 over here. Similarly, the value for x of 1, you can see, is nothing but 7 over here. So like that, you can substitute the other values from the given sequence in the expression of x of z, and then further you can simplify it to get your final expression, as we can see over here. Now this expression of x of z will converge only for those values which are not equal to 0 or infinity, because as you can see, here x of z is having the terms of the z which are having the positive powers as well as negative powers. So therefore, when z is equal to 0, the terms with the negative powers will make x of z is equal to infinity, and when z is equal to infinity, this expression will become infinite. So therefore, as we know, the ROC is nothing but those values of the z for which x of z becomes finite. So therefore, we cannot include 0 and infinity in the region of convergence. So therefore, the region of conversion will be simply the values of z, the magnitude of z, which values will lie between 0 to infinity. So here we are having concluding note by considering the previous examples which we have discussed in the earlier session and today's session. So according to the first example that we have discussed in the Z transform, that is for the sequence a raised to n u of n, which is nothing but the right-sided sequence. So for right-sided sequence, the ROC will be generally the outside a circle whose radius is the largest pole in the magnitude. Here it was the largest pole was A, and therefore we were having the region of convergence outside the circle whose radius was equal to A. Similarly, for the left-sided sequence, which we have expressed as an a raised to n u of minus n minus 1, its ROC was inside the circle whose radius was the smallest pole in the magnitude. Here it was A, and therefore we shown the ROC is lying inside the circle whose radius is equal to A. Similarly, for the finite duration sequence that we have just discussed, the ROC will lie between 0 to infinity, So generally we can say that for the finite length sequence, the ROC is the entire z plane except perhaps for z is equal to 0 and or z is equal to infinity. What if we are having the both-sided signal? So here we have expressed both-sided signal by just adding the left-sided as well as right-sided signal, and that we can for that we can express that ROC will be nothing but the angular ring in a z plane between the circles where z is equal to a and the magnitude of z is equal to b. And it will not contain any poles. So it will take a strip it will take the structure of an angular ring in a z plane, um, as you can see in this particular diagram. So this is how for the respective signals you can have the ROCs as well as Z transform by considering the method that we have just discussed now. So you can consider these are the examples that you can uh, consider for the self-assessment by using the method that we have just discussed now. Thank you.